Hello students, you are welcome to Physics 121, which is General Physics, and today's lecture is on transformer. My name is Faisal M. Usman, and I will be taking you on this journey. Now, transformer is an electric device that we use to step up or step down voltage in an AC circuit, and it consists of primary and secondary coils that are wounded on the same iron core. With me here is a simple sketch of how a transformer looks like with its component. A transformer, as you can see, has secondary and primary components. In the primary component, we have what we call number of turns. The NP here represents our number of turns, and then the VP represents our potential difference across the primary, and also NS represents our number of turns in the secondary, and Vs represent our voltage or potential difference across the secondary. What it means is that you might have seen this before, but you don't actually know it's a transformer. If you are to check your mobile phone chargers today, or some of these our radios, small radios, you'll find out that you see something that is being wrapped. Sometimes they use tape, yellow or red tape, to cover it. If you are to open that thing, what you will find is something like this. You find out that this here is a laminated iron core. You find these wounded coils here, usually what they use is copper wire. So that's what you will find here. They use it to wound, and the number of turns on the transformer are basically counted. It depends on if the transformer is a step down or step up. That will determine how the number of turns will be wounded. We have the primary coil, we have the secondary coil. So here is another representation of what a transformer looks like. You can see here we have a voltmeter that also contains a transformer. So from there now you find out that it has primary coil and also secondary coil. In the primary coil it has 1000 turns, and also in the secondary coil it has 100 turns. This means that what it's telling you is that if the number of coils in the primary is higher than the number of coils in the secondary, it tells you if the transformer is a step up or step down transformer. So as we go along in the lecture, we'll be able to realize when we have high number of turns in the primary, what type of transformer is that? And when we have higher numbers of turns in the secondary, what type of transformer is that? You can also see that there is another voltage there of 2000 volt RMS across the primary turns. So as we go further, we'll be able to understand what a transformer looks like and what it does and its functions. Even though, of course, I believe we know some of the functions of a transformer. Now, the working principle of a transformer is based on Faraday's law of electromagnetic induction. What it does, it converts high voltage into a low voltage, or convert a low voltage into a high voltage. All this depends on the type of transformer that we have. We have another one that we call an ideal transformer. What is an ideal transformer? Ideal transformer is the type of transformer that the input of that transformer is equal to the output of that transformer. Or better still, you can say that is a type of transformer that has no loss of any kind. What it means is that whatever you put in that transformer is what it will give you out. That means that's the type of transformer we call it has 100% efficiency, which means the power in the input of that transformer will be equal to the power in the output of that transformer. So that type of transformer is what we refer to as an ideal transformer. Another thing is the relationship between the electromotive force and the current is inversely proportional. It's inversely proportional, and also the number of turns is directly proportional to each other. What it means is that if you look at that equation over there, where you have ES basically, this is what the statement means. The ES here, in some materials, in some books, you will find out that instead of E, they use V to represent it. So either V or E, depending on what you define it to be, it's still the same. What it's telling you is that it's the electromotive force across either primary or secondary. It says the electromotive force is inversely proportional to the number of turns. So these are the number of turns either in the primary or in the secondary also. So the E here is the same thing as the V. So in some materials, instead of using E, you'll find out that they are using V. So as the class goes on, I'll be using both the two so that you'll be able to understand that you can encounter it with either E or with B. So just make sure that you know which term is which. So that will help you to understand the parameters very well. So let's define our parameters before we proceed. So when we have NS, what it means is number of turns in secondary. And when you have NP, what it means is number of turns in the primary. And now our VP is talking about the voltage across the primary, and also VS is talking about what? Voltage across the secondary. So if you see this, because as we proceed further, we'll be able to use the terms NS, NP, VS, BP, even IP and IS. And we know that we use I to represent current. So whenever you see I, either IP, what it means is the current across the primary, or IS, which is the current across the secondary. So these are the terms that we'll be using as the class proceed. So back to an ideal transformer now. We say that an ideal transformer is a type of transformer that has no loss of any kind. An ideal transformer has 100% efficiency. Whatever you put in the input is what you have on the output. That is why they say the power in the input is equal to what? The power on the output. And of course, from our knowledge of physics, we know that power is defined as what? IV. Current times what? Voltage. Now, we have a transformer, that's an ideal transformer, that says the input power is equal to what? The output what? Power. And that means what? If you have power to be equal to what? IV in the input, that means on the output also you are going to have what? Power to be equal to IV. Now another thing is the fact that you have power in the input, meaning either power in the primary or power in the output, power in the secondary, depending on the type of transformer. Is it step up or step down transformer? If this is the primary now and this is the secondary, all you have to do is that just indicate by using the subscript either PB like this, and then for this one, that means the current in primary and the voltage in primary will give you the power in the primary. Also the current in the secondary multiplied by the voltage in the secondary will give you the power in the secondary. So this is an ideal transformer. It has no loss of any kind. Whatever you put in the input is what will give you as the output. So this is another representation of some explanations that we are going to encounter. From here now, you see the difference between a step-up transformer and a step-down transformer. So you see, as I said earlier, in some materials you see they use the term E instead of V. But while here, you can see here in the slides we use ES. Even though while doing the explanation, I'll be able to use V so that you'll be able to understand. We'll use both the two together and solve the problem. So these are the major difference between a step-up transformer and a step-down transformer. In a step-up transformer, the secondary voltage is always higher than the primary voltage. And also the number of turns in the secondary is higher than the number of turns in the primary. What that means is these are our number of turns. If now you break a transformer and open it and you realize that the turns here are more, once you look, you see, okay, I have number of turns in the secondary than the primary. Basically, you'll be able to know that this type of transformer is a secondary, is a step-up transformer. You'll be able to know that this is a step-up transformer because a step-up transformer, the number of turns in the secondary is always higher than the number of turns in the primary, which means the potential difference across the secondary will also be what? Higher than the one in the primary. Again, that means if the potential difference and the number of turns are higher in the secondary, it is expected that the current will also be higher in secondary than the one in the primary. So these are some of the major differences between a step-up transformer and a step-down transformer, which will help you when you are trying to solve a given problem. So let's proceed. Now, mathematically, if you remember, we define our ratio. We define this ratio to be Vs all over what? Vp which is equal to what? NS all over NP. Remember, the V here is the same thing as the E on the slides. So the V here represents the voltage across the secondary and the voltage across the primary, while this tells us the number of turns in the secondary and also what? NP, the number of turns in the primary. Now, if this is settled, this is built, then we also define our ideal transformer to be what? IPVP is equal to ISVS. This is what we define an ideal transformer to be. Remember, IV is power. So this is the power in the primary and also equal to the power in the secondary. So if we do some mathematics here, by let's say we try to divide everything here. If we try to rewrite this, we can also rewrite this in this form: IP all over IS is equal to VS all over VP. So simply what we did here is that I collect the like times to this side and also the other ones to the other side. I can simply divide through by IS to have this, and then divide through by also what? VP, so that I'll take away the P here, then I'll have this. So if this is agreed, basically we have VS all over VP is equal to IP all over IS, and initially we have VS all over VP to be this. So we can conclude that if VS all over VP is equal to NS over NP, and now we also see that VS over VP is equal to what? IP all over IS. Then basically you can also say that it is also equal to what? IP all over IS. We are going to make use of this formula to solve some given problems as the class go on. So from the step-down transformer, you see that what it tells you is that the potential difference or the voltage in the secondary has to be less than the voltage in the primary. As we earlier stated, now you can see the vice versa is the definition or is the representation of a step-down transformer. The number of turns, when the number of turns in secondary now are lesser than the ones in the primary, you clearly know that this is a step-down transformer. So just please take note of this. This is a very, very important statement that you should make sure you get it clear. The first statement says that if the number of turns in secondary is greater than the number of turns in primary, then the potential difference or the voltage across the secondary will also be greater than the voltage across the primary. And if this statement holds, then we'll call it what? A step-up transformer. So two things: number of turns higher in secondary, higher than the number of turns in primary, which will lead to number of voltage in secondary to be higher than the one in primary. Basically, when you have this, you are talking about a step-up transformer. And likewise, if the number of turns in secondary is less than the number of turns in primary, then the voltage in secondary is also less than the voltage in primary. Now, when you have this statement, then you know that you're talking about a step-down transformer. So when you take note of these two, I believe whenever you are solving a problem, you'll be able to know that, okay, when you are being given a parameter, you know which one to put, you know when to put, and you know which one is which, so that you proceed and solve your problem. Now, applications of transformer. Like I earlier stated that there are so many places where we can see transformer and where we can make use of it. Like the welding machine. Of course, if you go to all those people that weld metals, you'll find that they have a huge engine that they use to power their machine in order to weld your metals or something, whatever it is that you want to weld. Now, the content on that welding machine also has a transformer in it. Is it a step-up transformer, a step-down transformer? You have to go there to find out which one is which. And also in our X-ray tubes, if you go to the hospitals, you find out that also our X-ray tubes contain transformer. In our mobile charging phones, our mobile chargers that you see now that contain some AC circuit in it, if you break the charger, you are going to see a transformer in it as well. You see there's a component there that sometimes they wrap it, like I said, with a tape. It could be red tape or yellow tape. If you were to open it to remove the tape, this is what you find inside. You will find this laminated iron core is usually a metal that they use. Then they wrap this coil around it. They wrap this coil around it, and then some other things that will follow. Then you see some wires attached to it, which will be the output and the input. One can be the primary, one can be the secondary. And again, another application of transformer is to transform electric current through metallic cable. Of course, this is the one we know from this. This is the one we are familiar with. The movement of electric current through the metallic cables that we see around. Other applications also that we can use in transformer, like I earlier stated, in an AC circuit, one, to isolate circuits electrically, and then again, a step-down level of transformer can be given in a single phase to be what? 11 kilovolts up to what? 220 volts. If it's a three-phase, also it can be from 11 kilovolts up to what? 440 volts. These are all applications of transformer. Now, take note of this. At a power station, this is what happened. A step-up transformer is used. So, from the source where we generate our electricity at a power station, what they use there is a step-up transformer. What it does there is that the primary is connected to the source, because this is a step-up transformer now. So, in a step-up transformer, the primary is always connected to the source. Another point that should be taken. A step-up transformer, the primary section of a step-up transformer is connected to the source. That's one. Then the secondary section of the transformer is the one that they will use to transmit it to us. So that means a step-up transformer, what it does, it increases the voltage. So from the source now, when they generate the electricity using their own transformer there, when the primary is on the source, the secondary is what will be to us, because they want the voltage to be increased so that it will be enough to transmit to surroundings and industries. Now, that is one. When it comes to the consuming level now, in our surroundings, the transformers we see around are the ones that we use that give us off light. Those transformers are step-down transformers. After they must have gotten a high voltage and high current from the source, now using the transmission line, when it comes to our transformers in our domestic use, those ones, they are the ones that they will use them to step down and reduce the voltage that comes from the source. It reduces the voltage so that we'll be able to use it in our homes and also industries. That is why most of the times, the voltage that is being generated from the source, you see that they use high cables, and you don't usually see those high cables in our surroundings. Probably maybe out of town when you are traveling, that's when you get to see all those high cables. And if you are to stand behind them, sometimes because of the strength of the voltage, you can even hear the cables making a kind of weird sound. That tells you the strength of the voltage that is being gotten from the source. And now that voltage is what will be in our step-down transformer, the one we use in our homes, which will help now to step down and reduce the voltage, and then what? To distribute to our homes and industries. This is another point that should be taken. A type of transformer that is being used from our electricity generation is that from the source, they use a step-up transformer to generate the electricity and get a higher voltage that they will use to distribute. And when it gets to our transformers that we use for our domestic use, now our transformer helps to what? Decrease the voltage. Now, the type of transformer we use in our homes which decreases the voltage is a step-down. It steps it down, decreases it for us so that we're able to use it in our homes. So this is how electricity is being generated. And again, it is used for impedance matching. We'll get to see this as we go further in the other modules of the lectures, and we'll get to know what an impedance is also talking about. These are applications of what? A transformer. Now, another thing is what we're going to look at is a transformer efficiency. When we say a transformer efficiency, what do we mean by that? An efficiency of a transformer, as you can see here, it says that what? The power in the output divided by the power in the input times 100 will give you the efficiency of a transformer. Or the power in the output all over the power in the output plus the power loss times 100 will also give you an efficiency of a transformer. So these ones will be used when you try to solve a problem. Of course, there are a lot of examples and exercises that I have attached in the note, which I will distribute to your various classes for your own use. So you see a lot of examples there and exercises so that you'll be able to solve them and understand, and also know how to apply a given formula when a problem is being asked. So again, another definition of efficiency is that the power in the output, efficiency is what? Power in output or power in secondary. Power in secondary all over what? Power in primary times 100. So output input depending on the type of transformer you use. So here now, if you see power in secondary of that, this is definitely a step-up transformer. So the power in secondary all over the power in primary times 100 will give you the efficiency of a transformer. So take note of that as well. So and remember, what did we define power to be? Power is defined as what? IV. So that means you can also define your efficiency to be what? Since this is the power in secondary, you can also define it to be IS VS, which is I represent the current in the secondary all over what? Power in primary, which is what? IP VP, and which is what? The power in primary then times 100. Basically, this is the efficiency of a transformer. So in any given problem, if you are asked to solve a problem on transformer, this is basically the method to adapt and solve a problem. Now, I have some questions and examples that I want to take us on this journey to solve, and then you also try and solve the exercises. So let's pick these examples one by one and solve them and solve each of the problems so that we'll be able to see how to solve a given problem in transformer. The first example there says that what is the turn ratio required? What is the turn ratio required in a transformer to step down 250 volts to 50 volts if the secondary current is 2 amps and the resistance in the primary is 10. Now, one thing I want you to know is that when we talk about turn ratio, basically NS all over NP. This is what we refer to as turn ratio. The number of turns in the secondary over the number of turns in primary is what we mean by turn ratio. Now, a problem is being given here that says, what is the turn ratio, which is the NS over NP, required in a transformer to step down 250 volts to 50 volts if the secondary current is 2 amps? Now, the question is, you are going to ask yourself is, what type of transformer is this? Is this a step-up transformer or a step-down transformer? That's one. Secondly, be able to bring that, because when you are being given problem in physics, the first thing is try and understand the question and then bring out all your parameters. When you are able to bring out the parameters, it will help you to know, okay, this is the method to take to solve a given problem. So let's try and bring out our parameters so that we'll be able to know what type of transformer is this and then how to go about solving it. Now, number one, the question asked us is, what is the turn ratio? Turn ratio, NS over NP. We define it to be our turn ratio. Now you have from the question, you are going to have VP, you are going to have VS, and then you have, because it says the secondary current, meaning current in the secondary, which is what? IS. These are parameters that you are going to have, and then the question asks you calculate the primary current. You are going to calculate what? IP. So this, once you're able to bring out these parameters, give them their values, then it will help you to solve a given problem. Now, from the problem given to us, our VP is equal to what? 250. How do I know that our VP is 250? Is because from the question it says, what is the turn ratio required in a transformer to step down? Basically, we know the type of transformer and we know what you are looking for. From 250 to what? 50 volts. And also, now your VS is what? 50 volts. And then you have the current in the secondary is given to be what? So the unit of current is ampere. So we use the what? Amps. And then they ask you to calculate the what? Current in the primary. Now our turn ratio, since this is a step down transformer, our turn ratio is what? VP now all over what? VS, which is equal to what? NP all over what? And because now remember, this is the turn ratio that they are asking you to calculate. No, so that's the turn ratio, but they're asking you to calculate what? The current. So number one is, once you be able to do this, VP over VS is what? 250 all over 50 is equal to what? NP all over NS. Remember, this is a turn ratio. By the time you punch your calculator and divide this, you are going to have NP all over NS to be equal to 5. Now, 5 turn ratio. Now, this is the turn ratio for this transformer that is being given to you, because remember, the turn ratio is defined to be this. So once you're able to solve this problem, whatever you have is your turn ratio. That's the first part of the problem. Now you are able to solve your turn ratio. And also remember, when we were at the beginning of the class, we use an equation that says IP over IS is equal to what? NS all over NP. So that is how to go about. Now you know what your turn ratio is. So all you have to do is what? Substitute it and substitute the values for your IS, and also go proceed to find IP. So from there now, we already know that IP over IS is equal to what? NS over NP, which is our turn ratio. This is NS, this is NP, yes. So which is our what? Turn ratio. So here now, remember, your turn ratio has already been calculated to be what? 5 turn ratio. So therefore, all you have to do is that IP all over IS is now equal to what? 5. So from here now, you are able to have IP all over IS to be equal to 5. So when you cross multiply this, you are going to have IP, because this is now over 1. So you are going to have 5 times IS is equal to what? IP. Now, remember, our IS has been given to us to be what? 2 ampere. Therefore, 2 now times what? 5 is equal to IP. And then this will give you what? IP will be equal to 10 ampere. Now, this is the current you have in the primary. So what this tells you, of course, is that this is a step-down transformer, because a step-down transformer has a higher current than a step-up transformer. And also, in a step-down transformer, the number of turns in primary is higher than the one in the secondary. So that's how you get to know that, okay, of course, you are correct, this is a step-down transformer. So in a given problem, I might not tell you whether it's a step up or step down, but when you calculate and find your answer, you'll be able to tell me now what type of transformer is it. Is it a step up transformer or a step down transformer? The second example says a step up transformer is used on a 120 volt line to furnish 1800 volts. The primary has 100 turns. How many turns are there in the secondary? So remember what I said. All you have to do is that bring out your parameters. It will help you to know, okay, this is the problem and this is what you have to solve. So number 2 question now, number 2 example, a step-up transformer. They have already told you that it's a step-up transformer. So of course, a step-up transformer will have high voltage than in the secondary than in the primary. A step-up transformer, the voltage in secondary is higher than the one in primary. That is one, of course. And also the number of turns in secondary has to be higher than the one in the primary. So remember our little ratio, that's what? VP all over VS is equal to what? NP all over what? NS. Where we also know that VS all over VP equals NS all over what? NP. So the question asks us to do what? A step-up transformer is used on a 120 volt line to furnish 1800 volts. The primary has 100 turns. What you are looking for is what? The secondary. You have the primary turns, you are now looking for the secondary. So these are the parameters you have to use. So the voltage in secondary, voltage in primary, the number of turns in secondary, and then the number of turns in primary. So since they've already told us that it's a step-up transformer, all you have to know is that a step-up transformer must have high voltage in the secondary. Then you look at the problem given to you, the voltage that is higher there is 1800 volts. That means what? The voltage for the 1800 is for what? Is for the secondary. And also for the primary now, which is lower, is what? 120 volts. Now the question asks you to calculate the number of turns in the secondary, but they gave you the number of turns in the primary to be what? 100 turns. So all you have to do is key in your parameters in this equation and solve your problem. Or you can easily make the ns the subject of formula, so that after you make it the subject of formula, then you solve the problem. And now, how do you make this the subject of formula? The first thing to do is to cross multiply this equation. When you cross multiply this equation, you are going to have ns vp to be equal to what? Vs np. Remember, what you are interested in is ns, which is the one they ask you to calculate. So if you divide both sides by vp, in order to get rid of this vp, all you have to do is divide everything here by vp. Also, divide this one by vp. So at the end of the day, you see that the vp here will cancel the vp here, and you are going to be left with ns to be equal to vs np all over what? Vp. Now you can key in your parameters and solve your problem. Your Vs, which is the voltage in the secondary, is given to you as what? At what? 1800 times Np, which is the 100, the number of turns in the primary, all over what? Vp, which is the voltage in the primary, which is 120 volts. So by the time you punch your calculator, you'll be able to have a figure. So I'll leave you to finish this and get the answer for this one. Now the third example we have is, the third example there says, a step-up transformer operates on 110 volts line and supplies a load of 5.0 amps. The ratio of the primary and the secondary is 1:25. Determine the secondary voltage, the primary current, and the power output. I'll expect these questions it's quite easy actually, just like the other questions that we solved. So please try and also try this question first. Then if you find any difficult, the solution of the problem is in the note that I'll distribute to your classes. So, but I want you to try the question first to see whether you'll be able to solve the problem before you look at the solution in the example. So after today's class, I believe by now we have been able to define what a transformer is, applications of transformer, what we use transformer for, types of transformers. Is it a step-up transformer, a step-down transformer? What we use step-up transformer for, what we use step-down transformer for. Remember, the transformers we see in our domestic homes are step-down transformer. The ones we get from our transmission lines from the source are step-up transformer. They help us after getting a high voltage, coming to to the environment. Now we cannot use the high voltage. Now they have to use the step-down transformer for us, then to reduce the voltage and distribute that voltage to our homes. We have also talked about ideal transformer. We've talked about efficiency in a transformer. So these are simple things that it's expected that at this level you should be able to know and solve a given problem. Like I said, I have other examples in the lecture note that I have included, about 7 to 8 of them, and then also there are other exercises that I expect that you should try them. They are not difficult actually, so make effort, try and solve those problems. Once you're able to solve the problems, I tell you, you will not have any challenge as far as this module is concerned. Thank you very much. See you next class.